common challenges with Data Vault data modeling today. I'm Neil Strange, chairman of the group. I do occasionally present at these sessions. This is one of the rare occasions where I've been sort of sprung into this at the last minute. Hopefully I'll have something of interest to share with you today, and very open towards the end if anyone's got questions to open the floor to questions that people might have. Right, so I've been data modeling since a long time ago, and I was trained by Richard Barker, if anyone remembers him. So that goes right back to some of the earlier data modelers in the industry. Richard Barker has his own form of notation that he used, very strong within Oracle. It's sort of become a second language to me, well, third, fourth, or fifth language maybe, but it's quite a natural way of expressing things, and I find it very useful as a way to understand the data that you're working with. I find lists of schemas very difficult to ingest. I do like to see like a two-dimensional representation of the data that I'm working with. Now, it does need specific skills. You have to be able to concentrate. So it's one of those skills where you're working at an abstract level, but also in the detail. You need to be able to concentrate, keep yourself nice and consistent. Data modeling is actually a social skill as well. You need to facilitate and work with other people, some of whom are not that technical, to try and get an understanding of the data that you're working with. You need to have good business understanding, so you can pick the good words and terms for what you're working with. You need technical knowledge because you're designing underneath all this data structures, so you need to understand how things might perform or how things may work. And language skills, so picking the right words and making sure that things are phrased correctly. So it's not for everyone, but I think it should be a wider skill than it actually is. And I also genuinely believe for today's marketplace, it's a very useful skill to have, particularly as we're getting into sort of semantic understanding of data, whereas a good data modeler works a lot with semantic levels of understanding. Now, in the old days, it wasn't a particularly agile skill. You'd sit down for days or weeks on end to get a good data model out, and then sort of freeze it and feed it to the developers to work from. But with agile coming in, struggled with getting it working with agile until I started to work with Data Vault, and that Data Vault's got this lovely set of techniques in there, which actually finally makes data modeling an agile skill. Data Vault allows you to work in small lumps, put it all together in a larger picture, and to refactor as well, and sort of keep just ahead of the development team and be useful. Now, I want to talk about a few challenges today. So the first thing is, how on earth do I get started? I'm looking at a blank piece of paper. What do I do to get something down on paper? Modeling to extreme. So what does that mean? Well, what if I become super abstract in my modeling? Is that the right way to go? Units of work. Now, that's a specific thing for Data Vault, but very powerful way of making sure that the data set you're working with doesn't get out of control. Can I break the standards or not? The answer is no, not normally, but yes, you can. A dilemma between am I looking at a hub or am I looking at a link? So I'd like to sort of explore some of those and then how you might go about solving them. But there's plenty more challenges that people have. But for me, these are the sort of top 5 things that I see out there. So first of all, some observations out there. So Data Vault has a limited set of table types. So you've all probably heard of these hubs, links, and satellites. But there are other table types in there. You've got special types of links, like non-historized links. There are certain types of satellites, like multi-active satellites, record tracking satellites, and so on. And you can also have reference tables in there. But in essence, there are really just three types of table: hub, link, and satellite, and variants of them. So it's like a palette. You're given three or four colors on a palette, and it's your job to mix them together to paint the picture that you want to paint. So you're going to be working with hubs, links, and satellites, and you can model practically anything you wish just using those three building blocks. And there's lots of advantages with having those three things because that then reduces the sequel to a templatable form. So you get different data modelers. Now, data modeling is a craft. So different people will produce slightly different types of model. Just like coders, if I sit three coders in a room, ask them to write me a Python program, you can definitely pick out their styles in the choice of words, the choice of the functions they use, the libraries that they like to access, and so on, the packages they access, rather. Data modeling is no different. And you might have data modeler A, who likes abstractions. So they're into things like terms like party and role and things like that. Maybe data modeler B is into a slightly more physical representation. So their tables, their designs look a little bit closer to um, actual objects. So instead of having party in there with roles, they may identify suppliers and customers and employees and so on as separate concepts in their diagrams. And they're both working with the same building blocks, but you get different results out. Now, question there is then, which is best? So you can see possibly you can go too extreme in either direction. I can be very, very abstract. We have a not very funny joke in data modeling that you can reduce any system to two tables, which is thing or thing type, or four tables rather, thing type, thing relationship type, and you can fit everything into those structures. And in fact, some of the underlying models in some of the CRM systems use that sort of level of abstraction. Or you can go far too physical, and you can end up very, very close to an operational system with all kinds of spurious tables in there that may or may not be of any use for a business analyst. So obviously there's a Goldilocks zone in the middle where it has a slightly more abstract feel or a slightly more physical feel about it. And the answer really is it depends. So first of all, you are sticking with the data modeler that you have. So if you think more abstractly, then a slightly more abstract model's fine. If you think more physically, a slightly more physical model's fine. And one of the rules of thumb here is you should look at your source systems basically, and if your source systems aren't abstract, then you should tend to model slightly more physical. So what we're saying is don't abstract away from the source systems too much in your modeling. Otherwise, you'll be spending a lot of time with rules trying to action all that abstraction. So basically, out of that discussion, we're saying data modeling is a craft; it's not a science. So your two different data modelers will produce two different models. So you get what you hire in here. Got the chat coming in. Yeah, sorry, recordings. We will record this. I am recording this, and we will put this up on our website at the end, which you're welcome to access. It will also go onto our YouTube channel. So yes, people can see this when we finish the session. Okay, so two different models produce two different models, and you get what you pay for. So you get the kind of model that your modeler's happy with. Now, the good thing about Data Vault, because it's agile, it allows you to refactor and iterate. So if you have a data modeler that loves abstraction and they wander too much into the abstraction space, you can start to refactor it back the other way later. So you're not fixed on a particular level. You can modify and get this into a pattern that works for you. Come on. Right. So I like to think basically choice is good. So if I could do it abstract, I can do it detailed. It doesn't really matter, and I can also refactor. That gives me the flexibility I need to work in a really agile way. So it means I can cut something early on that's sort of right and gets me moving, and I can then refactor and adjust it as I go forward to bring it back into maybe a better, more efficient way of design. Okay, so this choice is good. I can model the same thing in many ways. Um, yeah, but the other problem attached to that is then someone's got to make a decision. So how good is this model? Are we in the right space? Do we need to make a change here? Okay, so there is a qualitative decision that needs to be made here about what level you want the rules to be the model to be at. Okay, so this comes really on then to rule two. So the first one is that it's a craft. Second rule is that you need to apply judgment and apply common sense to what you're doing. So you cannot switch your brain off and do modeling. So what do I mean by that? Well, Voltaire, of course, says, common sense is not so common, but the sort of things we I see in this space is, can we use shortcuts, for example? So sometimes you're modeling something, and you could model it in a complicated way or a simple way, and you model it in a simple way, possibly with some physical elements in it, just to get the project over the line. Yes, fine, do those shortcuts. But whenever you do that, you're building in data debt or technical debt, and you really need to take time in your schedule to tidy up that debt. If you leave it in the system, it will come back and bite you multiple times over because of inefficiencies and workarounds that people then need to do to get the data out. Now, the other thing is with common sense, just because the source system uses a name for a concept doesn't mean you need to keep it. Yeah. So, for example, I have seen someone set up a CRM system to hold contracts, but they stuck them in the proposals table. Yeah. And they basically had a rule in house that says, well, if you see proposals, we actually mean contract. Um, doesn't mean you should continue to use the word proposal in your model to represent contracts. Yeah. Common sense here. Name things after what they are. So just because it says so in the source system doesn't mean we have to keep the name there. And other things like for expediency, if you have the same thing, the same concept, but your business users have two different names for them, don't create two hubs and a same as link to join the two together. Actually challenge them. Don't take an order from them. Challenge them. Go back and try and work out what an appropriate name is for that concept. And to be honest, you can pick a name for the data vault and change the name when you get to the presentation layer, depending on which users are accessing that data. Okay, so apply common sense. It's very important. Right. Rule three. Oh, it's the it depends rule. Whenever you looking at modeling something, there's genuinely not a right way and a wrong way of doing it. There's generally various forms of right. So it's a grey decision. So almost any model's right, as long as it's well thought through. But whether it's the appropriate one for the particular business problems you're trying to solve is a judgment call. So all data models or all data vault models that you produce are useful in some ways, but you might want to tweak them to make them more effective inside the business problems that you're working with. So, for example, again, if you went back to look at best way of thinking this. So I was working with a client a couple of years ago, and they had records of contacts with customers, and often customers would call up and claim that they hadn't made a particular contact. So, for example, a customer had cancelled an account with them, then changed their mind and came back and claimed that they never cancelled it in the first place. And rather than argue with the customer, what they wanted to then do was just delete the fact that the customer had applied for a cancellation. Now, I'm not going into the niceties of whether you should be doing that or not, but this particular customer was doing that. And they wanted to find a way of modeling the alteration of history inside their systems. So they wanted to know that, yes, they had requested that in one historical timeline, but later on they wanted to adjust the timeline to have an alternative timeline where the customer didn't delete the relationship with them. And we spent quite a while pushing that model round, came up with three or four ways of modeling it, neither of which were particularly attractive. We had to pick one of them as to the best way forward. And then the question is then, well, which one was the best? Well, they say it depended on the circumstances. So it depends is a good answer, because you can always make it work with different types of modeling there. So okay, so kind of getting started. So I've already said to you, Data Vault's made up of simple building blocks and simple rules. We've got hubs, links, and satellites. So surely it's going to be easy to build up a data model. But reality is a bit different, isn't it? You think the data is going to work a particular way, then you open up the source data that you're getting, and there's all kinds of issues in there. It doesn't quite make sense. You can't work out why certain things are the way they are. And what we have to do is to apply some heuristics, some standard ways of resolving issues, to resolve the problems that data throws up for you. So that's where the craft comes in. Yeah, you are applying heuristics that you've developed over time to get yourself modeling inside your project. So yeah, data modeling, you get better at it as you apply it, basically. So the only way to get better at modeling is to do it. So get on with it. Right, so getting started. When you start data modeling, you often look out at the sources that you're going to be processing. And, each source system has dozens or hundreds of tables in there. And you think, oh my goodness, what am I going to do here? I've got, one HR system, I've got a finance system, I've got 3 CRM systems, I've got a website, and so on, all to process, all to start modeling. Where on earth can I start? And you also find that you don't have time, yeah, because you're under pressure. Your team's looking for data models to work from so that they can start building out a solution. So you've got to really get cracking through these tables and start modeling them so that you can bring them into the warehouse. And you just sort of start at the beginning and just keep going down that list in a prioritized order. So for my mind, often it's not the best place to get started. So it's not really a mechanical process. So what I would recommend is that for now, yes, have a quick look at the source tables, get an idea for what they are, and you might want to profile some of them a little bit just to get an understanding. But once you've done that, kind of move them to the side and think about this from a business problem point of view, a business level. Okay, so if you try what's called bottom-up modeling, well, let's look at the problems with bottom-up modeling first. Okay, so we have our source system. Now I'm going to be very general here and a little bit rude about what source systems are, but let's imagine we have a system that we're using inside our business, and basically the vendor that's given us that source system has a history behind them in terms of how they've ended up with this system. So maybe you say 10 years ago, that vendor had built a one-off custom system for a specific customer. Okay. And then the vendor thought, well, hang on, we've built this system for this customer. It's actually quite a general solution for a particular process. Maybe we can package this up and start selling it to other customers. So they make some efforts to set it up. They make it configurable in some ways, but somehow it's still baked into that system how that first customer worked. So it'll have terminology in there, it will have some structures and processes in there organized around that first customer. And it's almost like a kind of history you can, or archaeology you can do inside systems, and you can see layers of building of functionality over time in there. So yes, if that system's been going for 10 years, you have multiple developers working on them. Each developer has a different style of coding. Sometimes they experimented with different methods, design approaches. So you sometimes see in a source system a mix of technology and design approaches. And they don't always go in and tidy things up. So you've got redundant code. You may have tables of data which are no longer used properly. Comments may not be true. All that sort of thing is quite common. Um, and quite natural in here. Your vendor's under pressure to add new features all the time. And so they've got a choice, every time they do a release, do they add new features or do they refactor the code? And of course, management will always choose new features over refactoring. So you get this technical debt built into the source system in over time. And the result of that, the code's a bit messy, the database is a bit messy in its structure, a bit inefficient, and so on. Now, that's part of the problem here. If you go to the source system and bring in the source tables and start modeling based on those source tables, then you're basically going to inherit whatever mess is in there as part of your data warehouse design. And then when you come to take data out of the warehouse, you're having to navigate around that mess and building in nasty query patterns and code structures to get data out. And in fact, if you look online and you look up Data Vault and read about people's experiences with Data Vault, one of the things people do mention is trouble getting data out of the vault. And I think you'll find in those cases that that's where they possibly over physicalized the design and biased it towards a source system design instead of building it top down. Right. So yeah, as it says here, we don't want to preserve any of the fictitious concepts. We don't want to have the misnamings in the source system. We want to, where the source systems has key value pair extended attributes in their extensions, we want to be able to recast those into business terms and so on. So we've got to be careful that we're not keeping that source system in our warehouse. So for rule 5, then your source system based models are an anti-pattern. So you should be using the business problem you're working with to design a top-down model, and then you map the source system data models into that top-down to allow you to validate that the top-down can be populated. So what does top-down mean? Well, you should be looking at the business context. So what I normally do is I start with the business problems, the business questions that the users are trying to answer. So if you're working in an agile way, you should be tackling a business problem at a time. So let's say there was a business problem around we don't know how many customers we've got, for example. So a lot of organizations find it difficult to count how many customers they have because the customers are spread across, multiple divisions, multiple systems. There's some duplicates in the system as well that they want to take steps to have some control over that number. Now, as a result of that, you may need to look at things like the business processes involved to understand how do we get customers on board across our various parts of the organization. And from that business process, you can start to identify concepts. And from those concepts, you can build out concept models and get the terminology out correctly, because the terminology needs to support the process. And from there, you can identify the business events that occur, and from there, what we call units of work. What are the main activities that are performed inside those processes that allow us to run those processes? This is a bit abstract, so let me give you an example. So onboarding customers could be an example here. Maybe we're doing a know your customer, a KYC check as part of a regular thing to bring customers on. So you have a business process that's performed for a KYC. You're going to capture some data from your customers. You're going to perform some background checks. You're then going to assess what you've learned and then approve or disapprove the customer in there. That's the basic process. So the concepts in there are things like customer. Other concepts in there might be related to where they're incorporated. Might relate to who are the key officers in there. Might relate to the bank that they're attached to and the status of their financials. All those sorts of things may be related to the process. And those concepts are identified, and then we can start modeling those to get an idea of how the structure of the data model comes together. Then we can then look at the source data that we have, and then we can start saying, well, does that source data fit into those concepts? Can we sort of package it up and force it in? If we can, that's good. It shows that we have the data we need to support the model that we've developed. If data is missing, then we may need to go back around the loop again with the top-down model to recognize the fact that, yes, okay, maybe something should be there, but if it isn't, we need to get a model together where we can at least populate the structure with some source data. So that's the reality check. And we resolve differences through that process. Now, this is quite an interesting thing, because when you work with a data vault, this top-down model actually is just the hubs and links. So the hubs are your concepts and your links are your units of work. And so you can model those top-down using business terms for reflecting those. So you shouldn't see anywhere in the hub or the link sort of system-oriented terminology. The bottom up is where we take the source data essentially and work out where it fits inside that hub and link structure and start pinning data sources against where they fit in that top-down model. And if you've got nowhere to pin a particular thing, then possibly you identified a hub or a link. And if you've got hubs and links without anything attached to them, then you would want to question whether or not those actually exist in the source. And the other thing you'll be doing as part of that bottom-up check is validating that you've got primary keys that work across the system for the various concepts at the top end. So you can identify whether you're going to use a proper business key in there, or you need to construct something out of the source system keys. Basically rule 6 then is, yes, the data vault gives you a chance to get away from how the source systems are designed. But again, you can only get away from them if the data's there. So you're sort of captured a little bit in the orbit of the source system, but it gives you a chance to have a big cleanup in the way you refer to and represent data. Okay, rule 7 in here. You really need to be involved with the business. So data modeling is a communication technique, not just a technical drawing technique. So you need to be worried about business alignment as much as you need to be worried about technology and databases. Okay, so you're going to be sitting with users to validate and check things, check that the language is used is correct when you're working on the top-down part of the part of the diagrams. So Yeah, so let's have a look at these things with what I call extremes. So here we have a data model. So we have a sale, um, and sales made on a day. Days within a month, within a quarter, within a year, and years have weeks, and days are within weeks. Okay, so that's analysis of sale by a calendar. And we also have a regional breakdown of those sales. So we have sales are made within a district, districts are within a country is within a region. Okay, nothing too unusual in there. And so if I follow the data vault rules, then I end up with something like this, or do I? Data vault says we have to do all this. We have to break everything down into hubs, links, and satellites and build this complicated model out. Well, no, it doesn't. Okay, so this is an example of where you really need to keep your brain switched on. And I have seen one project where all the roll-ups, all the layers in roll-ups were modeled as separate hubs and links. And they had somewhere in the region of 60 or 70 hubs in a model representing every layer of roll-up. And the whole thing performed, when he built it, it performed really badly, which is, hey, surprise, surprise. So someone didn't have their brain switched on when they modeled and built out that system. So let's have a look here. You know, we can't have 9 source tables mapping to 38 targets. There's an explosion of hubs, got links everywhere. Um, this is an unwieldy and unsuitable model. So let's have a look at what's going on here. It's wrong, basically. What we need to be looking at is units of work. So what's going on here? You know, the unit of work is a sale, basically. And within that sale, we've got various assemblies of hierarchies. So let's have a look at one way we can simplify this. So if we got all these there, first thing is really to say, why are we modeling year, quarter, month, and week in here? You know, they're types of calendar period. Okay, and calendar periods are not really part of a unit of work. They are a presentation layer thing. Yeah, they are when you cut your star schemas or your presentation there, you want to know which week, day, month, and quarter and stuff they're in. They have little relevance to the capturing of the transaction that you're modeling here. So we can actually get rid of that from the diagram. That's a lot simpler, isn't it? But then we've got a similar issue underneath. If you look here, we've got that the geography aspect here, we found that the country and region structures are largely fixed inside of our network. They have a very limited number of countries, limited number of regions. And therefore, if they're fixed, why am I modeling them as hubs and links? Why am I going to be doing every time I get data coming in? Why am I going to be checking if they need to be updated or not from the source data if they're always fixed? Seems a bit of a waste. They're more like reference tables. So maybe I can remove those and maybe I can create or I can roll them back into the satellite of the hub district. I can add the country and region in there and not necessarily model them that way. How about that? And I can then declare the country and region as reference tables. So suddenly we're down to 2 hubs and a link in the model. But then what happens if we've only got a few districts? I mean, if a district never changes as well, I can probably roll those back into the satellite on the hub sale. Yeah, so that satellite in the sale can have a reference table linked to the district, and that reference table can give me the hierarchy in there. And I don't need to do anything more than that. I can basically reduce that model then down to just a single hub and satellite. Okay, so which is best? You know, I've got this complicated assembly on the left with lots of hubs and links. I can simplify it by removing the calendar. I can then simplify it further by abstracting back the district structure. And if the district's also a reference table, I can represent that as a single hub and satellite. Look at the difference in complexity. Look at the difference required there to get queries running, you know? So the answer is really you could use all of them. They're sort of equivalent to each other in many ways. But probably the one you want to choose is a simple one on the end there to work with. So, you know, like I said there, you've got four choices for a model. Each of those options is valid. So they all work. Choice you're going to try and make is, what's the most appropriate variation for that particular project's needs, the particular problem you're trying to solve. Now, if I come back up here, you might choose the second one if you had a lot of variability in the countries and regions and districts, if they were frequently changing. Which would allow you to model that frequent changes. But because in this particular business, if they're very fixed, you can simplify that right down to the right-hand side. Okay, next thing is on unit of work and granularity. So remember I was talking about earlier on, if you've got a data architecture background, when you do data vault modeling, you tend to view your modeling as an exercise in enterprise data modeling. What does that mean? Well, that means that you look everything as normalization, abstraction, and the application of patterns. So you tend to use concepts like hub party, hub role type, and stuff in there, which reflect the sort of enterprise models that you put together. And remember that earlier on that could be a bit a bit abstract. So for example, if I've sold a life insurance policy, then as a data architect, you'll think about quotes, policyholders, beneficiaries, person insured, and so on in your model. And you'll probably put something like that together. Okay. So you've got hubs there for quotes, policies are valid for periods, policyholders, life insured, underwriters, and so on in there, and they're linked together with links. Now, there's a bit of a data modeling spell in here. If you see lots of two-way links, you're probably not modeling at the right level of grain because you're building up a hierarchy of connections in here. Got a question coming in. Sorry. No. Okay. So too many two-way links. Right. So what you can do then is, can I reconstruct that data? For example, what actually is going on here in the business? If you look at what's going on in the business, what we're doing is I'm trying to convert a quote into a policy. So that's the business event. Policy quote becomes policy. How would I do that if I wanted to reconstruct that? So to reconstruct the conversion of a quote to a policy, I'd need to join together all of these hubs and links to make a single query. That's not very helpful. Data Vault would say you should model it a slightly different way. You start with the activity, which is converting a quote into a policy, the business event. That becomes a link. And then we hang the objects related to that policy, to that event off of that link. So we have something like that. So if I want to query my underlying system, I would tend to query around that business event, give me a list of all the conversions that have happened. And if I have a model like this, where I've got, essentially one big join in the middle with 5 hubs underneath them, I can quickly reconstruct anything I want to know about conversions. But also looking underneath here, each of these hubs is essentially a different dimension. And I could, for example, give me all the quotes that have been converted into policies, give me all the quotes that were issued to a particular underwriter for work? How many underwriters what is the count per underwriter for converting quotes to policies? I can answer all those questions from this little diagram very nicely with a simple amount of SQL in here. That's all because the link is modeled at the unit of work grain. All right, standards. There's a lot said in the Data Vault community about standards, and you need to follow them and everything like that. And basically, they're right. But this is the basic reason why a lot of people start working with Data Vault. They don't get trained in it. They're working from the book, and they start their first project, and they look at the Data Vault building blocks in the book, and then they say, well, I think I can improve on those. So they implement their version of Data Vault and don't follow the standard building blocks that are recommended for the method. Fine, okay. But later on, the project fails often for the reason where they modified the rules. For example, some people might put start and end dates in links, and that isn't allowed in the standards, but you feel like it needs that, and then you find that the system doesn't scale as well as it should have done. And that's as a consequence of what happened there. Anyway, say the project failed. Oh, don't know how that happened. Come back up. There we go. Project failed. They say, well, then clearly Data Vault isn't appropriate for our kind of project. It's essentially a bit like driving a car repeatedly into a wall. If you keep doing that, it's probably not the car's fault. It's probably the fault of the driver in there. So Data Vault is a simple diagramming technique with a set of rules attached to it. Apply the rules, follow the rules, and you'll get a better result than if you go off-piste. So the reason I'm saying that is I can point you at loads of examples of successful Data Vault implementations where all these nice things are coming in on the back of that, and basically do not break the standards until you've had some experience in using Data Vault. Because not following the standards can be a major cause of project failure. So standards are being, use the hub, link, and satellite, use the right metadata, follow the naming conventions, follow the permitted connections, handle business rules in the standard way. And yeah, once you understand why they're there, then you have the experience to flex them a little bit where necessary. Right, last thing I'd like to talk about, how are we doing on time? Yes, just about right. We get this dilemma very often with people saying, is this a hub or is it a link? And I'll explain what that is and ways of thinking about this. So here's one example. I have a hub, a journal, a financial journal, and there are transactions entered into the journal. And we would normally say that links are used to model transactions in a system. So a journal contains transactions. Transactions are entered into a journal. And then we have transactions are double entry. So we'll have postings in the ledgers. So each transaction will have two or more line items in them where they have different sums posted against different accounts, and those will obviously balance. So yeah, transaction details are posted in accounts. Now, Data Vault says you can't connect links to links. So we'd have to have transaction and transaction detail out there as separate links on this. And we'd have to store transaction ID twice, once in the transaction link and once in the transaction detail link. Now, think about this. Perhaps that's where we have to make them join. Perhaps we could view a transaction as a hub. Maybe. If that was the case, then I'd end up with something like this. A hub transaction has the details at the top there. postings against the account. The details are also contained in the journal, and transactions are placed in journals as well. And this is interesting because I started off with the transaction as a link, and then in the end I've promoted it out to be a hub, and the transaction lines I've modeled as a link. Okay, so I quite often model my financial systems this way. Seems to work well, but you've got choices. So which is best? Well, okay, the answer is, of course, it depends. But other areas where you can have issues is where you've got semantics. So there's a nasty thing about natural language. It can misdirect you a bit. So a word you use can be both a concept or an event. Same words used for both. And in cases where that is, you often find the double meaning of concept and event rolled into one source system table. So in the source system, it looks like it's one thing. And when we do modeling, we may have to tease them apart. So I'll give you an example. Maybe we've got a purchaser and a supplier, yes, signing a contract. So contracts are made between a purchaser and a supplier. And if you look at the contract table in the database, it will have foreign keys linking purchaser and customer tables, maybe. Well, let's assume it does. So we could model it that way, couldn't we? We have a contract. It refers to the purchaser, refers to the supplier. But contract is used for as a reference by many other business processes. Yep, I may invoice against a contract. Okay, I may enter into a legal case over a contract. So contracts are also concepts in their own right. So I've got perhaps a need to create the hub for that. So I've got a hub contract, supplier and purchaser, and then this sort of link there, which do we call that contract as well? It's not good to have the same name for a hub or a link in there. So maybe there's some language term in here that we're not quite getting right. So, is a contract a link or a hub? Basically, it can't be both, and we can't have them named the same. So if you look at the language a bit more, what is a contract? What's the purpose of a contract? What's the event that happens here? And what you basically find is that a contract is created when we have a legal agreement. I mean, we're not going through the drafting process here, but let's assume this is a signed contract. It's an agreement. And that contract is referenced by other processes. The link in there should record the business event. What's the business event? The event is a legal agreement or contractual agreement happening. So we end up with something like that. Okay, so the unit of work is the business event that's happened, which is the contract agreement, or you can put signing the contract in there, something like that, and end up with your purchase, supplier, and hub off of that. Right, so that's about run out of time. I'm going to come back to the questions in a minute. So there are lots more things I could talk about. What about non-historized links? How do we get effectivity satellites to work? What happens to history if history can change? What if you have lots of system surrogates to use and so on? And Data Vault's got answers for all of these, which would take another time to cover off. So in conclusion, then, I think Data Vault modeling is data modeling, but it's separate enough in the way we approach things to be different. It's quite rich and varied, and you can support agile ways of working. But it still has to deal with all the ugly stuff that you get with regular data. So I've covered off a few topics today, but there's a lot more out there. Gen AI, I think, can help a lot here, but I think you still need to apply human judgment. So I think Gen AI would be an assistant for a human modeler to help them perform better and move faster. But you still need that human judgment in there to know what is a good model and a bad model. So thank you. You can reach out to us, say on our website, or my email address if you want. And as you probably found us already, this will be up on the Data Vault forum in there in the near future once we've cut the video for this. Right, I'm looking to see if anyone got any questions. So I've got two questions in here. So I've answered the one on the video. Right. I think there's no any questions there. I've got one from Alexi asking, could there be more than one contract? Yes, there could be. Exactly. So the primary key of the link, sorry, the contract entity itself would need to identify the primary key for the contract. So it may well have a contract reference number on it, and therefore the link would have we'd have separate links in there for each contract that had been signed. Yes, so that's another reason to put it out as a hub. What technical performance gains to be achieved by using a star schema, faster columnar data in retrieval? The star schema stuff is down to how you render the data product that comes out of the data vault. So you think of the data vault as a normalized storage area for all the data. And then on the presentation layer, the marks that come out the far end, that's where you'd put the star schema in there. Peter, did you have a question?
Yeah, when you say it's not automatable, I guess my question to that is it's automatable to a point. I think there still does need to be the application of judgment, but is it fair to say that it's not automatable
Well, I've
because the
certainly,
last mile isn't?
no, I've certainly used it as starters. So, for example, I've asked ChatGPT. I've sort of said, I'm in this industry. I'm looking at this process. Give me some ideas of what concepts I need to be looking at here and what activities are performed, and then use those as a source to go out and interview the users in that area. And then from there, built up a model, then used ChatGPT to assess the quality of the model, also to do the things like glossary entries on it, and then converting it over to a data vault. Um, can be done because you basically the concepts tend to become hubs and the lines connecting concepts tend to become links in a model. So yes, you can get I think you get an approximation of the data vault model out, but you still need to query and question the or drive the system with clever queries.
Sure. Oh, thanks for taking the question.
Yeah, thank you. Um, right, Eben, what do you do if it's basically the same concept, but the business keys differ from the sources? Right. So first thing is, if it's a business key, my definition of business key is it shouldn't differ between the sources. If you're talking there about source system keys, then the rule in Data Vault is you should use a business key if you can find one. If you can't, then you have to fall back onto the source system keys as a way of working. And then you need to introduce a collision key. You need to identify the source system that came from, use the source system key, and then go back to your master data management to get same as links out to be able to join that data set together. So by not having business keys in the source systems, you are paying the data debt that's in there, created by the source systems not being well organized or well structured. Yes, so Will's right on that. You can actually build source system vaults, and you end up with all the mistakes that I mentioned in there if you use source automated solutions to work with the source data to build a system out. Okay, anyone any further questions? If not, I'll say thank you very much, and hopefully you enjoyed that. Apologies for not having the advertised speaker, but we're going to chase Chad down and find out what the issue is and try and get him up for a future event. So thank you everyone for attending, and we will hopefully see you again at a future event.